To use tiles, we want to solve 2x and then minus parentheses x plus 1. Remember that means to build on the bottom. And then x plus -5 plus x. I've already built it with the tiles. And this is what it looks like. I have my 2x, which that's the 2x here, and then minus x plus 1. So on the bottom, minus x plus 1. And then on the right side, I have an x. So that's the x right here, plus -5. I know that's on top because there's a plus between it. So plus -5 plus another x. Okay, so I have it built, and now I'm going to solve it and write the steps. First thing in the table, I always write the original. And then I like to flip things so that we have everything that is separated by plus signs. So only on the left side did I have to change anything. And how this looks different is still I have my 2x. But now it's plus -x plus -1. And that's really the distributive property that I'm using. The right side stay the same. So I have x plus -5 plus -x or plus x. And you could use the distribute property. Otherwise, you could say that you flipped. But really, I distributed that negative to the x as well as to the 1. So the next step, now that I have it flipped, I want to do if there's any zero pairs, or called combining like terms. So I have a zero pair on this side. These positive and negative x cancel each other out. And I don't have any zero pairs on this side, but I do know when I write it that I'm going to combine the like terms. So I'm going to move these x's together. So on the left side, I added the 2x plus -x, and I get an x plus -1. And on the right side, I'm just going to combine those, 2x plus -5. Oop, that should be a 2. And I'm going to call it combining like terms. Okay, now I have an x and unitiles on one side, x and unitiles on the other. So I need to start moving things. Actually, I can take off balanced sets. So I have an x on the left side and the x on the right side. I can take those off because it doesn't change the value of anything. They're the same value, but I'm taking both of them off. And I'm going to take a unitile off the left side and a unitile off the right side, a -1 of each. So what I'm left with on the left side is actually 0. And what I'm left with on the right side is x plus -4. And I took off balanced sets. Now, here's the problem. I have everything on the same side. I need to move one of these over, and I might as well move those negative. So I need to move those. The only way I can move those is by making zero pairs. So in order to make zero pairs on the right side, I'm going to add 4 unitiles. And then on the left side, because whatever I add, I have to add to both sides. I'm going to add that on the left side. And what happens now is these go away. Oops. And my answer is going to be x is equal to 4. I've isolated my variable. It's by itself on one side and the unitiles on the other. So what that looks like here is I added 4. So I got 4 on the left side and x on the right side. And I added balanced sets. You can actually say added 4. On this one, we can say that we took off balanced sets, we took off x and -1. And so when I get down here, my answer is x is equal to 4.